We should be recording. Yep, little red dot. We're recording. It worked. All right, we are going to learn how to use something called the sine law. Let's read through these notes together. It says, in previous years of math, you've learned how to solve for missing angles and sides of right-angled triangles. But what about triangles that are not right-angled? In order to solve the triangles that are not right-angled, and the word for that is oblique triangles. That's a fancy word that means doesn't have a right angle. The two words that are more specific are, remember, acute, all the angles are small, and obtuse, one angle is bigger than 90, right? So oblique triangles, which can be acute and obtuse, need a different tool. You can't use SOHCAHTOA on them. Why can't you use SOHCAHTOA on them? Well, SOHCAHTOA implies that you have a hypotenuse. If you don't have a right angle, you don't have a hypotenuse. So we need something different. Here's a formula that we're going to call the sine law. And wow, that looks weird. Since when do formulas have two equal signs in them? Don't let that panic you. At the end of the day, we only ever need two of these three parts to do a question. So I think the easiest way to do this is to just jump right in. And the first lesson here, there's actually two lessons we're going to go through, lessons 2 and lesson 3, because they're basically the same lesson in two parts. And lesson 2 talks about finding sides. Now, I like this example, but I think I'm going to go back to it. Let's do an easier, in fact, you know what? The easiest example here is example 4. I want to jump to page 8, and let's do example 4 first, because it's the easiest. Okay, so there's triangle ABC, and in triangle ABC, I have to find side C. That's what I'm looking for. Here, I'll highlight it with my highlighter. There. I want to find side C. Okay, so I have this formula. It said that 2 pages ago. Don't worry, you don't have to memorize this formula. We will give it to you on a formula sheet when we test you. Yay. Formula sheet. Okay, so now, obviously, I need this part of the ratio because there's the thing I'm looking for, right? So I need this piece of the ratio right here. I'll highlight the whole thing. Now I told you I only ever use 2 out of the 3 parts of the ratio. So which other part do I want? Well, notice I'm going to use a different color. Ooh, blue. There. Notice I know angle B, and I haven't labeled it yet, but this is side B, and I know that. So I need to use this part and the yellow part. I need to use those 2 parts. So I'll just write them by themselves. In fact, I'm going to rewrite them. I'm going to put C over the sine of C is equal to B over the sine of B. So I wrote it backwards. It doesn't really matter what order you write an equation, left or right or left. And you might be thinking, well, what happens to A and sine A? Why'd you leave them out? Why did you exclude them? Don't worry, don't feel bad for them. We'll use them in the next example. But you never need all 6 things in this formula, right? 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers, 6 numbers. You don't need all 6 ever. You need 4, and of those 4, you need to know 3 of them. And I know 3 of them. I know that angle C is 73 degrees. I know that side B is 14.2. And I know that angle B is 15 degrees. So the only thing I don't know, which is the thing I'm looking for, is side C. And now it comes down to the math. Once I've figured out the formula and how it looks and which parts I want, how do I punch buttons here? And some people called it this yesterday when we were doing SOHCAHTOA. Think of the 2 words cross multiply. Really, at the end of the day, it's algebra. I'm multiplying both sides of the equation by sine 73. But again, some of you, algebra is not your favorite thing in this universe. That's cool. Think of it as this number crosses up to here and multiplies that top number. That's why they call it cross and multiply. So C will be the sine of 73 times 14.2 divided by the sine of 15. Let's make sure we can all punch buttons together. Anybody need to borrow a calculator? Okay, come and grab one. Everybody else, I don't mind if you use your phone again. Between now and test, make sure you've got a real calculator. You can't use your phone on the test. But to be honest, these things work better than your phone. Your phone's not a bad calculator, but I like the calculators where you hit sine first and then put in the number. It just makes life easier. Although, we did see yesterday, a couple of you have the kind of calculator like this guy. Let me bring up my calculator. Yeah. How many people are in the boat like this? Sine 73. And do you notice it opened a bracket for you? A couple of you got that? You do realize, we talked about this yesterday, right? That means close the bracket before you go times 14.2. Those of you who don't have it open a bracket for you, you don't have to worry about it. But those of us who do have it open a bracket for us, that means if I don't close the bracket, the calculator will think I want the sine of whatever 73 times 14.2 is, which would be an angle so big you'd have to like spin around to get to it, which is bigger than a triangle. So that's not the angle we want. So that's my top, and then divide by sine of 15. Since that's the last number I need, I don't really think I need to close that bracket, but I'll do it just to be safe. And hit equals. Oh, I never checked to see if I was in degrees. Oh, last time I used this calculator might have been with the pre-calc kids. It might not be in degrees. This might not be the right answer. Oh, it is. Okay, we're in degrees. Okay, so that's the answer. C is, what was that number again? 52. Okay, what's my rule? Yeah, it didn't say where to round, so let's round to 2. So in 2 places, that's 52.47. And there is a unit here, degrees. Any questions on how I did that? We have an assistant in the room who can walk around and help you out if the buttons aren't going right, because I'm going to stay up here with my microphone. Oh, thank you. I'm asleep. Somebody just pointed out, this is not a degrees, this is not an angle. This is a side. I started talking about what units it is, and then I forgot. This is not degree units. What units are we in? Meters. That's better. Thank you. Thanks for being more awake than me. All right. I said that was the easiest example. Let's roll back to example 2. This one is harder by 1 step. It's not a big step. It's not the toughest step, but it is 1 step harder. Here's why it's harder. Okay, I would like to know A. So I obviously need A over sine A. Problem, what's this side here, this 36? Can you see me highlighting it? What side is that? That's side B. Well, side B is in a ratio with angle B. I don't know angle B. What can I do? 182.23. Exactly. Remember back in lesson 1, we learned the trick about there's always 180 degrees in every triangle? So my first step is actually to figure out that angle B is 180 minus the other 2 angles added up, 53 plus 46. Do we need the calculator for that? Maybe we do. What's 53 plus 46? That would be 99. Oh, no, we don't need to calculate that. If you went 180 minus 100, you'd get 80. But you're minusing 1 less than that. You're minusing 99, so 81? So this is 81 degrees. So that's what this angle up here is. And now I'm ready for formula. I need to know this A part, but I know that number. And I know the B number for the side. And I know the B number for the angle. 3 parts out of 4. That's kind of the way again, I always like to think algebra. That's the way all math works, right? You can't really solve equations that have more than one unknown thing in them unless you start making systems of equations like they taught you in grade 10. So this is it. This is how we do it. Oh, and that's supposed to say 1, not L. There we go. Okay, so the question that I'm sure the microphone didn't pick up is, do I need to show this step here, or could I just jump to this step? You know what? Once you get comfortable with this, I don't mind if you jump to this step. Or conversely, if you're really comfortable with this cross multiply and you don't want to write down this step, I don't mind that. But please make sure you write one or the other. That way I can give you part marks if all you do wrong is punch buttons wrong, or read your calculator wrong, or oops, I was in the wrong mode for a second. Then I can see that you did it right. Okay, fair enough? All right, so we punch buttons again. I don't remember what the answer for this is. I'm going to punch buttons. Okay, let's move this calculator gets kind of finicky when I move it. Oh, good, it worked. Okay, so sine of 53 remember, I got to close a bracket. Some of you don't. Times 36, divide by the sine of 81 equals. And we are looking at 29.11 centimeters. No, it's not degrees, right? This is not an angle, it's a side. 29, I made that mistake last time. Oops, what was the number again? 29.11 centimeters. Okay, I'm going to pause the video and you're going to try the next one because it works exactly like this one. So see if you can do it without me. I'll pause the video and then we'll come back. So everybody trying this at home because they've missed class, see if you can do example 3. Pause the video, give it a try, and then start the video again. There we go, we're back. Okay, so let me catch up to you. First of all, I realize I would like B. So B is in this ratio with the angle across from it, sine of B. And I have been given angle A and angle C. Okay, so I don't know angle B yet, so I'm going to have to figure that out. So angle B is 180 minus 75 plus 35. Okay, 75 and 35 is 110, so 180 minus 110 is 70. If you're not comfortable with the mental math, please use your calculator. And I know side A and angle A, so that's the other part of the ratio I want. Remember, you only ever need 2 parts, you never need all 3. So I'm going to plug in angle B, which I just figured out is 70. So sine of 70 equals 23.6 over sine of 35. And now I'm going to do the cross multiply part. So sine of 70 times 23.6, all divided by the sine of 35. And again, if people are going, how is he doing this? What's this wizardry? Remember, this number here crosses to the top and multiplies with what's there. Cross, that's why they always called it cross multiplying. All right, give to me the numbers. Calculator on, it says on, there we go. Sine 70, oops, that didn't work. Sine 70, close my brackets, times 23.6 divided by the sine of 35 equals 38.66 centimeters. All right, now obviously this is only applicable to the real world if we actually look at a real world type problem. Here's a good one. So go back one more page to example 1. This is what you would call surveying, right? How do you actually figure out a distance without having to actually run the entire distance? I mean, I'd rather not have to swim across this river with a tape measure in my hand. So there's got to be a way to figure out the distance without having to swim and cross the river, and there is. It's called surveying. They use a piece of equipment called a, I don't know how to say this word, I think it's a theodolite. And if you've ever seen a survey crew when you've driven by, it's, you know, there's usually, it looks like a camera on a tripod that one guy's operating. Somebody else is standing further down the road with like an orange and white stick in their hand. And they are doing basically this. They're trying to figure out distances without having to stop traffic and measure directly with a tape measure across a road. In this case, we're going to find the distance across a river. Elliot's family owns a house in Gander River in Newfoundland. Their closest neighbor's house is 2.5 kilometers away. The surveyor uses a theodolite to measure the angles between the houses, so they see that it's a 65-degree angle there, an 80-degree angle there, and don't really need those lines. And a nearby communication tower, as shown in the diagram. Use the sine law to determine the distance from Elliot's house to the tower to the nearest tenth of a kilometer. Okay, so Elliot's house is what I'm looking for. I might as well call that, I'll call that A. That's side A. That's what I'm looking for. So that means if that's side A, the 80 is angle A. Because remember, you used your opposite rule there. So I guess I'll call Elliot's house point B, which means that's side B. And C for communication tower, C for angle C, which means this 2.5 kilometers they measured is side C. So I need to know what angle C is because the only side I have is across from it. So angle C is 180 minus 65 plus 80. All right, 65 and 80 is 145, right? Yeah. 145 minus from 180 is 35. Okay, so angle C is 35 degrees. And I now know this angle and that side, and I'd like to know that side. So A over the sine of A equals C over the sine of C. So I didn't use B at all this time. I could, but it doesn't ask for it, and it doesn't give me, you know, any indication that it cares how far it is from the neighbor's house to the tower. We want to know Elliot's house to the tower. So that's why I'm doing it this way. All right, let's put in the numbers. So side A is what we're looking for, and angle A is the 80-degree one. C is the 2.5 kilometers, and angle C is the one we figured out down here. I might as well label it 35 degrees. Oops, sine 35 degrees. All right, do cross, multiply. Sine of 80 times 2.5 is dividing by sine 35. So side A is, oops, that's not what I wanted to do. That's what I wanted to do. Sine 80, close my brackets, times 2.5, divide by sine 35, 4.29. Sounds reasonable? The thing after the 9's a 2. Oh, wait a minute. Hold on. Yeah, don't ignore the instructions. Nearest tenth. So go back to that number. It's 4.29. Which decimal is the tenths place? The first decimal. Yeah, there's no such thing as a oneths place. The first decimal is tenth. So 4.29 becomes 4.3 kilometers. So yeah, make sure you always do what it tells you. And if it doesn't tell you anything, just round it to 2. All right, I'm going to stop this video here because that's all the examples we have of finding sides. And then you can join us in our next video, which will be finding angles.